square, right? However, are those the only segments we can make? What are the other segments we can do? Across. So how many segments can we actually make? 6. Okay. Counter example. What's a counter example? Does anybody know what a counter example is? Okay. Kind of. Cole?
Kind of like on the other hand, this could happen as well.
Yep. It's a statement. Okay, so it's a statement. Maybe. That shows conjecture is false. Okay? In order to disprove a conjecture, you only need to find one counter example. That's it. One counter example, and you can disprove that entire conjecture. Kind of crazy, isn't it? Kind of nice, too. So, let's look here. Let me go to Keynote. Actually, I want this example first. Okay? The cloud of water leaving a blowhole when it exhales is called its blow. I'm struggling. Wow. A biologist observed blue whale blows of 25 feet, 29 feet, 27 feet, and 24 feet. Another biologist recorded humpback whale blows of 8 feet, 7 feet, 8 feet, and 9 feet. Make a conjecture based on the data. So what's a conjecture we can make looking at this data? Anybody have any conjectures that they can make? What do you notice? Okay, we don't know the height of the whale though. We don't know the length of the whale. That's telling us the blows. Which whale has longer? Go ahead, Kylan.
Oh, I was gonna say that each species stays in like a certain range.
Okay, so there's an average. We could say that. There's one that's very, very obvious.
Humpback swan.
Blue whale blows will have bigger blows. Blue whale whales will have bigger blows. It's that easy. Okay? You can make a conjecture based off saying that it's almost 3 times. But here's a bunch of different conjectures. The height of a blue whale's blow is about 3 times greater than a humpback whale's blow. The height of a blue whale's blow is greater than a humpback whale's blow. Like, it can be that easy. Okay, let's look at this one. Length of a female, length of a male. These are average whale lengths. What's the easy one?
Female's longer.
Female's longer. Are there any others you can see?
Male is shorter.
Yes. Okay. You could find the average of them both and be like, on average, it's about this. The female is longer in most of them. Female whales are longer than male whales. That's simple. Okay? So let's go back now to our notes. Notability. I'm struggling here finding notability again, sorry. Okay? There are some steps we want to follow for inductive reasoning. Right? Because to prove a conjecture, we want to show that it's true. So, the steps, the first thing we want to do is we want to look for a pattern. I don't want blue, I want orange. Look for a pattern. That's the first step. Look for a pattern. Then the second step is we want to make what do you think we're going to make? Conjecture. And then 3. Prove the conjecture. Or give what? Counter example. Okay? All right, we want to show that each conjecture is false by providing a counter example. Okay? For all positive numbers n, so any positive number, 1 over n is less than or equal to n. So what's the first n we should probably start by using and testing out? No, before that, we should start with 1. That's the first positive number. So we're going to start with n equals 1. Let's see, does that make sense? 1 over 1 is less than or equal to n, or sorry, erase. I said it right, and then I wrote it wrong. 1 over 1 is less than or equal to 1. Is that a true statement? Yes, okay. So is that a counterexample?
No.
So what do you think we should do now? Another n number. What number do you think?
2.
Let's try 2. N equals 2. 1 over 2 is less than or equal to 2.
Yeah, it's not true.
Okay. What do you notice? What number should I try now, do you think? I can't try negatives, it's positive numbers. Someone tell me. Okay? Is that true still? There is a counterexample. Think out of the box. Ben?
Negative 10?
For all positive
Zero.
numbers.
Oh,
Justin?
positive.
It's not a positive number. Cole?
What happened?
Let's try 1/2. Okay? So, when we do it like this, then it's 1 over 1/2 is less than or equal to 1/2. 1 over 1/2 is actually what? 2. I'll show you something in a second. Is 2 less than or equal to 1/2?
No. Nope.
No, there's a counterexample. Okay? Here's something to keep in mind with fractions. If you have 2 fractions on top of each other like this, that's the same as A times D over B times C. So in other words, here we have like 1 over 1 over 1 over 2. So what's my A, B, C, D in this problem? A is 1, B is, C is, D is 2. Okay? So A times D is 2 over 1 times 1 is, that's how I got 2. Or if you do 1 divided by 1/2, you're going to get 2. Okay? Do you see how that works providing a counterexample? You might have to try multiple things in order to get your counterexample. For any 3 points in a plane, there are 3 different lines that contain 2 of the points. So in other words, if I draw 3 points, 1, 2, 3. Does there have to be 3 different lines that go through all 3 of the points? No, what can we do? Just draw 1 line through them all. Pretend that line is through all 3 of them. And then I'm not a failure drawing on this thing. Okay? That's a counterexample. That's a counterexample. Okay? I'm going to put this on my iPad so you can see it. Not me. Sorry. Now I realize it tells you, okay, the conjecture is false. But look at this. The temperature in Abilene, Texas never exceeds 100 degrees Fahrenheit during the spring months. So what are the spring months? March, April, May. Look at those. Does it go above 100?
Yeah.
Where?
May.
May. So your counterexample is in the temperature of May was 107 degrees Fahrenheit. So the conjecture is false. That's it. And that's all I have for you today. And we still have 20 minutes left of class,
Wow, really?
which means you have time right now to get going on your homework. Okay? It's on that sheet.